Okay, we want to look at an overview of what a precalculus course is. And let's start by the statement that it's the basis of mathematical analysis. The basis of mathematical analysis is laid in precalculus. When you get to a precalculus course, you will have had a solid foundation, I hope a solid foundation, in algebra. Then precalculus becomes the transition course between what you learn in an algebra course and what you learn in higher level mathematical analysis. Now, not everybody is going to go on beyond a precalculus course. Of course, precalculus has to have use not just as a transition from the algebra to the calculus, from school mathematics, high school mathematics, to higher level thinking, but it also has to benefit students who are going to take mathematics that doesn't build on the precalculus. Now, there are other mathematics courses that use what you learn in precalculus. There's a difference between, let's say, a statistics course that requires a precalculus background and a calculus course. The statistics course uses precalculus but doesn't build on it. The calculus course, in a very natural manner, does build on what you learn in precalculus. Now, in a precalculus course, there are three areas that are kind of predominant. There are a lot of other things we learn around these areas, but there's the analytic geometry, which basically starts with the equations of straight lines and moves through conic sections. Matrices, which we start usually with the idea of solving linear equations using various methods, including matrix algebra. And matrix algebra leads on into linear algebra and subsequent courses, linear algebra being a course that's every bit as fundamental in many ways as a calculus course. You really can't do much beyond your basic undergraduate first 2-year mathematics courses without a solid foundation in linear algebra and in calculus. Now, again, not everybody goes into that, and there are plenty of applications of matrices for people who are not going to go beyond the level of a precalculus course. Excuse me. And there are the elementary functions, which is probably the most important, and it's hard to say that this is or this is not as important. Let's say that elementary functions are going to be the primary focus of the precalculus course. Okay, so elementary functions include what? When we study elementary functions, and I said include, so I'll say they include functions, power functions, exponential functions, logarithmic functions, polynomial functions, rational functions, and so forth. Actually, rational functions would not be included among the most elementary functions. They're built from the elementary functions. But the elementary functions, the very most basic functions that we use to build the functions that we study up through the first 2 years of the typical undergraduate mathematics curriculum. Again, these elementary functions are very important, both as a foundation for what we learn in a mathematics or STEM or physics curriculum, and also in courses, in areas of study that don't require much beyond precalculus. Okay, these functions are very important. They're used almost universally in almost every field. Okay, so when we study elementary functions, we study their algebraic properties, we study their geometric properties. I'm not going to elaborate too much on that. I'll do that in a subsequent video. Elementary functions apply to the real world. They model things that occur in the real world, which is why they're important, not only for people who are going to go beyond precalculus into the calculus and beyond, but for people who go no further. With elementary functions, we need to learn to construct graphs of transformed and combined functions. We're going to combine the elementary functions by arithmetic operations and composition. And having done that, we can begin to understand the elementary functions as the basis for functions and function families as entities. This is a fairly abstract idea. A function and a family of functions that is generated by this function by varying parameters, usually parameters that involve shifting and stretching transformations and other such transformations, rotations, reflections, and so forth, gives us a very powerful picture of the elementary functions and what can be done with them. Okay, so this is kind of the core of what we want to understand about precalculus. And of course, we're going to revisit this whole model again and again during the course, but this is a pretty good picture of where we're going. Now, there's a context for this course. One context of the course is modeling. We model things that happen in the real world. Okay, so this is important whether you're going to go on to a mathematics or physics degree or a very rigorous economics degree or whatever. But it's also important for anybody to understand who wants to understand the relationships within a field of study, the idea of modeling the real world using elementary functions, matrices, and analytic geometry. Okay? Then there is the transition to calculus, because at least half the people in a pre-calculus course are on a track that's going to take them either into an applied calculus course, which is kind of the last calculus course you take, or the much more rigorous engineering, mathematics, physics, chemistry, STEM, the mathematics-based STEM areas. Okay, so STEM meaning science, technology, engineering, and mathematics. If you're making this transition to calculus, we want to achieve a number of goals. We want to make calculus as easy and powerful as possible. Most students come out of a pre-calculus course and really don't have a very good foundation for calculus, so they keep stumbling over the calculus. Now, the goal here is to provide a really solid basis for a calculus course. And in the process, we sort of emphasize the ideas of rates of change, slopes, difference quotients, which are algebraic, geometric, analytic geometry concepts that are extremely important in the real world. Whether, again, you're going to go beyond the pre-calculus or beyond the applied calculus into the more rigorous courses, you have this concept, which is really central. It is the central idea of calculus. And then we have sequences and series. And I'm not going to explain or not going to refer to too much about what these do at this point, but sequences and series become extraordinarily important in courses, starting especially with a differential equations course and moving on into the higher level undergraduate mathematics curriculum and on through graduate mathematics and research mathematics and physics and so forth. Okay. Now, when I mentioned the elementary functions, I didn't mention the trigonometric functions, but they're also included. The sine and cosine and tangent functions, so the cofunctions, the inverse functions. Those are very powerful, very important functions. Sequences and series based on the trigonometric functions are extraordinarily powerful. We also, outside the context of functions, although in many ways related to it, we study trigonometric identities, triangle trigonometry, and vectors. Now, triangle trigonometry, again, is for real-world applications, especially for engineering and physics type applications, type curricula. It's foundational. It's very, very, very important. Vectors very, very foundational for a number of areas. And vectors we study in pre-calculus. They're related to matrices and matrix algebra in ways that we see later on. Matrix algebra is basically algebra on vector spaces and what a vector space is and so forth. We're not going to talk about that even later in the pre-calculus course. That's something you get in a linear algebra course. And the reason you want to study matrices and matrix algebra here is so that you can understand what a linear algebra course is telling you. Okay? So, other things that we develop in the course, we learn to formulate problems, or hopefully you've learned to formulate problems in algebra courses and geometry courses, and also mathematical foundations and proofs at a level appropriate to the pre-calculus, at a level appropriate to a transition to calculus, at a level appropriate to understanding in a deeper way that will stay with us longer just what it is we're doing with pre-calculus and its applications and the modeling. Okay, so, and we learn to solve equations. There are various equations. There are exponential and logarithmic equations in addition to algebraic equations, systems of equations, many, many types of equations. So we learn to solve a number of types of equations: exponential equations, logarithmic equations, trigonometric equations primarily. We learn to manipulate expressions and equations in various ways. And using our manipulative skills, we begin to learn to rearrange expressions and equations for various purposes. Okay, and then I can't elaborate too much on what the purpose might be. The form of an expression or an equation might change depending on what your purpose is, what it is you want to see within that expression or that equation.